Welcome back, everyone. Today we're going to continue our work with ellipses. All we're going to do today is we're going to examine some equations that are more scrambled and a little bit more difficult to deal with, but the same process of graphing and finding foci is all the same. As a reminder, here are all the formulas that go along with ellipses. So you've got basically a binomial squared over a constant plus another binomial squared over a constant, and that's always set equal to 1. These formulas down here help you find the focus distance, the distance from center to each focus point. Okay, I'm only going to do 2 examples today, and really there's just 1 or 2 algebraic tricks that we need to get over. So if you have a moment, copy this one down and give yourself a plotting area, or better yet, download and or print the notes that are posted on our website. Okay, this problem is not so different than the problems that we were doing before. So it's still a completing the square problem. You can see everything is scrambled, and we really want to start grouping things up in terms of like terms. So let's take everything with an x, put it on one side, everything with a y, clump all that up, take all the constants and move it over. And then we know this is going to be a completing the square problem, so let's insert those kind of fill in the blank constant terms to fill in. The complicating factor today is that there is now a coefficient in front of this x squared term, and I may introduce one later in front of both or either. And this causes a problem because this is not having a coefficient right there is not the result of FOILing out a binomial of this form. There's no number here that would result in having a coefficient out in front of that x squared term. So if it's a problem, we can get rid of it, or at least ignore it for now. So what I'm going to do is I'm going to factor out a 4 out of all 3 terms, even though that term doesn't exist yet. But I'm going to factor out a 4, so it looks like that. And now I can play that same game where I need to fill in the blank. Chop that in half and square it. So chop that in half, you get -1, square it, you'll get +1. Over here there's nothing new, so chop that in half and square it, you put a 4 there. So now what we've done is we've taken the original equation that they gave us and we've added some weight to the left-hand side. And this is the second tricky part today, is that I have not added 5 to the left-hand side. Take a moment, look at that equation. Can you see how much weight was added to the left-hand side? It's not 5 anymore. The trick is this. This 4 is being distributed onto the entire trinomial, including the 1. By adding a 1 there, I didn't really add a 1, I added a 1 times a 4 times this coefficient. So a total weight of 4 was added when that 1 was added. Additionally, I had this 4 right here, so to balance out the equation this time, I have to add a 4 and another 4 to keep the equation in balance. From there, it's a very similar process. Let's consolidate stuff. So let's add these numbers together to get 16. This is a trinomial that I can factor, so just chop that in half, and I have my binomial squared now. Chop that number in half, and I'll have my binomial squared. Notice that the 4 is still hanging out front. The second issue is that this equation for an ellipse is not equal to 1, so we learned how to deal with that last time. If we divide by 16, we'll take care of that. So divide every term by 16, that'll get us a 1 on the right-hand side and get us closer to standard form. Right here we have a 4 over 16, which we can treat like 1/4 or rewrite as 1/4, and then all of a sudden we're in standard form of an ellipse. So we can see that it is longer up and down than it is left and right. Vertical radius is 4, the square root of 16. Remember that everything in this term has to do with the horizontal aspects of the ellipse, so left and right, so we can figure out how far left and right the center is, and we can figure out how big the left and right radius is. So take the square root of that, we'll have our radius there, so that's 2. Take the square root of that, we'll get 4, and then our center is, remember they're the opposite signs, so 1, -2, so we have those pieces of information, and then we can use that focus Pythagorean theorem lookalike formula to figure out how far it is from the center to each focus point. And if you plug in the numbers appropriately, you'll get 4 squared minus 2 squared. That'll be 12. Take the square root of 12, you get 3.5. And then we have figured out that it's an up and down ellipse, so we're going to add and subtract that 3.5 to the y coordinate. You can do this after you graph the thing too, by the way. But if you wanted to figure out the foci before graphing, you can do it. And then if you graph all that, there's your ellipse with your foci labeled. Okay, this is our second and final problem for the day, so if you pause the video, jot it down and give yourself a plotting area. This problem is going to have a nearly identical process from beginning to end, so if you have high confidence right now, if you just want to pause the video and try to work through the problem totally solo on your own right now, go ahead. If not, follow along. So here we go, same process. I want to group all the terms with an x together. I want to group all the terms with a y together. We're going to move that 316 over to the right-hand side to just kind of store it, and we're going to insert our little fill-in-the-blank blanks for our future trinomials. So when we do that, it looks like this, and you'll notice that both x squared and y squareds have a coefficient out front. That's a problem for both of us. So let's factor each a 4 and a 25 out of each of the future trinomials here. So we'll factor out that. Remember that you have to divide the linear term by that number too. So you'll notice that that got reduced from a 16 to a 4, and that got reduced from a 200 to an 8. But now we have that coefficient out front. Once the coefficients are factored out, then we can fill in the blank just by chopping the linear term in half and squaring it. So chop that in half and square it, you'll get 4. Chop that in half and square it, you'll get 16. So we can fill in those blanks. And then now we have to balance the equation. So we added some stuff over on the left-hand side, so we need to counteract that on the right-hand side. So how much did you add to the left-hand side? Well, you have to take each of the coefficients and multiply it by what you just filled in with the blank with. So we'll get 16 there, and 25 times 16, I believe that's 400. So we'll have to add 16 and 400 to the right-hand side. And then we can start consolidating stuff. So we can add this together. We can factor this into a binomial finally. We can factor this into a binomial finally, and that's what we'll get in our second to last step here. So that all adds up to be 100. We got y minus 4 there, x plus 2 there. The only other issue here is that this is not a 1 over on the right-hand side, so we're going to divide each term by 100. We're going to simplify this fraction, so 4 over 100 would be 1 over 25, and 25 over 100 would be 1 over 4, so we can rewrite it just like that. And then we can extract center and focus information from this formula now that it's in standard form. It's easier to see. So we can see our center is -2 with a positive 4. We can see that our horizontal radius is going to be the square root of 25, which would be 5, and the vertical radius would be the square root of 4, which is 2. So that means that this ellipse is going to be wider than it is tall. So we can record all that information, and we can also calculate the focus points right there. So we go 5 squared minus 2 squared. Square root of 21 is 4.6. And you can see that I'm adding and subtracting that 4.6 to the x coordinate because we know we're longer left to right than we are up to down. If you combine all that information, you get an ellipse that looks like that, and you're done. Your assignment for today is to complete the 9.1b worksheet. You're going to do all the problems 1 through 5. Just a little note there that number 1 is not an ellipse. It's just a completing the square question. You don't have to graph it or do anything weird like that. It's just a single variable completing the square question. And then Schoology will ask for your responses to number 3 and number 4 today.